The Headspace visual design supports some of the themes from Andy's meditations. The idea that no two things are ever the same, and the idea of creating curiosity towards change. And as React Native developers, we have great primitives to build such user experiences. So welcome back, and let's get to work. Guys, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, we're going to look at the Headspace meditation app, and more specifically, the way you can nicely interpolate from the play to the pause button, so really friendly path interpolation. And you're going to see that this can be done extremely easily, and also the way the button animates in some sort of organic flow. And we're going to use a Perlin Noise for that. But let's start with the shape morphing. The first attempt was to rework the paths with Figma to have the exact same number of commands and the same kind of commands. Usually, we can normalize paths to sequences of cubic Bezier curves. This is an extremely tedious process because, as you can see here, once you achieve the normalization process, you still need to order the commands in a way that makes sense for interpolation. The second attempt of the path interpolation was really fun. I remembered that YouTube is also having a play button interpolation, but a much simpler one. This shape interpolation is fairly easy to build manually. From there, we can add a corner path effect from Skia to make it look more friendly. However, on the last part of the animation, we get a transition that feels a bit unnatural from this state to this state. What we can do instead is to apply a Gooey Effect. First, we blur the shape. Actually, we blur the bitmap of the shape and we use the layer property for that. This is because we want to apply the effect to the bitmap of the two shapes blurred together. Now, what we want is to sharpen every alpha value from this blurred bitmap. We're going to use a color matrix for that, and you will find its implementation later in the tutorial, and I think that you will find it to be extremely compelling. And that gives us our nice gooey effect. Now, another solution that requires even less work is to use a library named Flubber. This library uses triangulation to normalize the shape into a sequence of lines and normalizes the path so that each path has exactly the same number of lines. Flubber provides us with a function that takes a t parameter that goes from 0 to 1, and we need to integrate this interpolator tightly with Skia. We have a Skia path for the source and the destination. Now we create two more Skia paths. One if t is close to 0 and one if t is close to 1. And we know that these two paths can be interpolated natively from Skia. So if t is between t close to 0 and t close to 1, we return a Skia path interpolation. Isn't that cool? Now let's look at animating the circle. The solution to animate such a circle was hiding in plain sight all along. If you download the Headspace logo from the website and open it in Figma, you can see that the circle is not a circle, but actually a sequence of cubic Bezier curves where the distance of each control point is slightly different. Drawing a circle using cubic Bezier curves is something we've done before. We draw 4 points. We add control points with a distance relative to the radius, and we know that for c equals 0.5519 and so on, we get a perfect circle. I will link to an article on this topic in the video description. Now we need to slightly move the distance of the control points over time. We will use a Perlin Noise for that. We create a 2D noise for each point on the circle that will give us a random value between -1 and 1. The Perlin Noise is a randomized sinusoid, and we can change its amplitude and frequency to obtain the desired effect. But what do you guys think? Can it be done in React Native? Let's have a look. We are into VS Code here, and I have a small boilerplate which you can download from the video description in case you want to code along. And we're going to start with the path interpolation and the two ways of interpolating the path we looked at. We still need to do a little bit of boilerplate. So I have my Skia Canva here, and I want to toggle the state. So is it on or off when I tap on the Canva? And we want to create a progress animation value, which is going to transition the play button to pause and from pause to play. So we're going to add the onTouch event handler. So we can create onTouch, use touch handler from React Native Skia, and when we end the touch, we want to set toggle to the opposite value. And we want also to trigger an animation value. So we have a clock here, which we're going to use for having the progress of the meditation when it's on. So here, so we use an effect. If the path is toggled, we can start the clock. So clock.start, and if not, we can stop the clock. So now I need to update the array of dependencies. And we should also create a progress animation value from Skia, a Skia animation value. So progress equals use the value at 0, and here we can start an animation, so run timing on progress. So use value. Okay. We go to, if it's toggled, to 1, if not 0. Duration, 500 I guess is good, for 40 maybe. And we want some nice easing. So here Copilot is not correct. That would be, or maybe it's us who are not correct with our API. Sometimes Copilot knows better, but easing in out. But it's interesting, sometimes Copilot suggests something about what the actual API is. And if I think about it, I'm like, oh, actually, it should be the way Copilot says it should be. But anyways, is. Okay, so now we have our progress animation value, which we can use. I can add it here to the array of dependencies, which we can use to interpolate the path. Again, 2 methods. Let's look at the first one, where I built the path manually, where it's really simple. So the pause button is simply 2 rectangles. We create a new path, 1 rectangle, 2 rectangle. And then the play button is a triangle split in 2 for each side of the pause button. And we make sure that they have the same number of points than the rectangles. So here we receive the progress animation value as parameter, and we can use it to interpolate the path here. So we can use compute value. So we have path equals use computed value on progress, so dependencies progress. And we can return the path interpolation, which would be pause dot interpolate on the play path, and we know they're interpolable. And the t value that goes from 0 to 1 is progress.current. And here is complaining because the interpolation, sometimes the paths are not interpolable. Here we know they are, so it's not going to return null, it's going to return a path. So let me play. Yeah, perfect, right? You see it. Really fun. So it interpolates nicely, but of course it's very edgy, not very friendly. Can I make it bigger maybe? I think I should have like some scaling here from the other play button. So the bounds are the bounds of the path. So I can do bounds is, so maybe I take the play path and I say compute tight bounds. And so the rectangle is just an import. And here we have like some scaling, like based on the radius, which we get as property. So the scaled radius would be, I don't know, let's take 0.8 times radius. I mean, it's bigger, yeah. We just see it a bit better, it's a bit bigger. I mean, here it's a bit too big, but just for the sake of the example. So one thing we can do is to add a corner path effect. And we take radius, is it R? I don't know, 8, some random value actually. Yeah, so here you have a nice corner. And okay, so here we have a weird state, but we can merge the 2 paths together. If I go here, so we have the intermediary path, which we return. And I can do path.simplify, and that should merge. Yeah. So, I mean, it actually doesn't look too bad, right? But at the end, you see you have like one awkward switch, which happens only on one frame, so it's not really smooth. I think I mean, you can like play with it. So it doesn't really work, but, and maybe if I make the corner radius even smaller, or, yeah, you see, it kind of look okay-ish if the corner radius is quite small, actually. I mean, that looks quite okay, right? I think that would fool anyone, and it's like extremely simple to do. But for the sake of it, I'm going to show you two other ways of doing it. And but I mean, the idea, right, is that the methods we look at to build this example can be useful in all sorts of other examples. We are going to look at the Gooey effect, which can be used in a lot of use cases, and then we're going to look at the interpolation of any two shapes, which also hopefully should be very helpful in tons of React Native use cases. So I'm going to remove the corner path effect. And so, yeah, we're going to do the Gooey effect. So here we want to apply a blur and a sharp color matrix, but on the bitmap of the path. So not on the vectorial shape. And so we're going to use the layer property, which you can apply. So this creates a bitmap of what we've drawn, and you can apply a paint to it with some filters and everything. And here I'm using Expo SDK 46, so I can share with you the examples and so on. And so actually the way we're going to do the layer is deprecated. We've updated it. So the syntax, I mean, it's a very small change. The syntax is slightly different if you're using the latest version of Skia. I'm going to show you the change. It's very small, so this shouldn't be a big drama, hopefully. But so we're going to create a paint reference. Use paint ref. Once we have the effect running, I'm going to show you how, like, the different ways we can do the layer effect and how it's done in the latest version of Skia. But we can create a paint object. Using components, we can assign the ref to the paint. And so the first thing we want to do maybe is a blur with some, I don't know, 10, some random value. So it's blurred. And what we want to do is to sharpen, and we're going to use a color matrix. So you remember how we moved positions X, Y, Z using matrices, so we can scale, rotate, translate. We can do the same with the colors. So colors are 4 components, RGBA, and we can apply a matrix on it. And the matrix has the same like format, kind of than for a position. It's just that you have one more component. So it's like 4 dimensions, kind of. So we have a color matrix. And so the matrix. And so first we want to do the identity matrix. So it's an array of numbers. So here, of course, Copilot knows the values. But yeah, so we have so RGBA plus the offset, like for, positions. So then the next one we know is 0, 1, to have the identity matrix. The identity matrix is that if you multiply the color by this, which now is a vector of 4 components, by this matrix, you will get the same color. So yeah, Copilot again. And so the next one is going to be 0, 0, 0, 0, 1, 0, 0. Yeah. And here it says 0, 5. I'm not sure why, but we know it's 1. So this is for the alpha value. So this is the scaling of the alpha value, right? And this one is the offset of the alpha value. So this should, to some of you, this should look quite familiar. And so what we want to do to sharpen, we want to create some sort of really steep strip line, so that values which are, below this threshold are at 0 and values above are at 1. And then where this slope is happening, we decide it with the offset. So for instance, we can do a really sharp line by scaling the alpha value to 20. So a lot of values are going to go to 0 and lots of values are going to go to 1 immediately because we multiply everything to 20. And then we can offset it. Let's take half, so minus 10, for instance. And so you see here suddenly you have corners, right, because of the blur. And you have a small gooey effect, which we can customize. These values are really like highly customizable. Again, like just to give you a sense of, because to me it was not clear how this worked. So here we have the scaling value and here we have the offset value. So we know we have alpha equals this value. So alpha multiplied by this value plus this value. And so if we plot, so we have x, so let's say 20 times x. Just to, I think it's way better to plot it so we get a sense of really what's going on. Minus 10. So you see if we look at in the range 0, 1, so we have a really steep curve, and then we can decide where the threshold should be happening. Here at 0.25, I can do 15. So we really decide. And here if I do 40, I'm going to get a much steeper slope. I can even do 80 and then move it to like 40. So you decide, you see now if you look at 0, 1, you don't have a lot of values which are not 0 or 1. And so here you can really use it to customize. Let me do like maybe just to, if I do a small slope, so maybe 10, and then I move it to 5. I mean, here it looks, yeah, you see it looks already blurry, kind of. So 20 seems to be good. Yeah, you see customize also the threshold. Maybe let me put 18 so it disappeared. Because I guess everything went to 0. So you see, it's really interesting. So I can put 10. And so it's a topic we're going to look at in other examples, color matrices. We can do a lot of operation on them to do like filters on pictures and so on. But here a really nice trick to blur and then filter the alpha values to either 0 or 1 to build this nice gooey effect. And so that's one way that we can build the path. Pretty delightful. And the gooey effect, we can use it for tons of use cases, which we are going to look at in the future. And so now let's look at the interpolation of the two paths, but for any two paths. So right here, we take advantage of the fact that we know that these values are, that the path is like as a rounded corner and the gooey effect makes sense. But in some cases, it's not going to necessarily make sense. So let's do a path interpolation. So I have another path component where, so we have the Fluber to Skia path interpolator that we looked at. So we create a Fluber interpolator. We take a really small value. If the values is close to 0, we return the original path. If it's close to 1, we return the also original destination path. And if not, we use the Fluber interpolation, which is interpolated nicely natively from Skia. So here we have the original paths, which are not interpolable between each other. It's just two random paths. And we have some scaling, which I just want to make it bigger, maybe. Yeah, perfect. So we have the two interpolators, so for the left side and the right side. So I guess we can just use it directly. So we can create the left side, use computed value. And we're simply going to do, so we have the interpolator progress.current. So it's called left path. And yeah, so I have some typo here. And we do the same with the right side. So left, right, let's have a look. So here you see two random paths and they interpolate nicely. And one thing I want to show you is there is an option that we looked at also before in the explanation where we can decide the number of points we want the interpolated shapes to be. The default is 10, so for the max segment length, which seems to be more than okay. So let's say if I put 100 here, it should be very, look like a big triangle kind of. So you see, so I mean, here we don't see anything because we see the original shape, but as soon as I animate, yeah, you see, you only see Let me do like 50. You see, I mean, I can even only return, let's say, the version from Fulber. So you see, it doesn't look great. Yeah, that's funny. Here's the pause, but of course I can make it smaller. So at 10, it already looks good. You can do 1, you won't see any differences. So 10 seems to be a great default, and I guess they understand also maybe, you know, that we are going to work with icons, so the size usually is going to be in this range. So 10 seems to be a great value here for good measure. If it's not animating, we want to return the original path. But yeah, so a fun way to interpolate two shapes. I think it's going to be useful in tons of use cases. So really exciting, really fast, thanks to the Skia path interpolation, which is done natively. So yeah, really cool stuff. So now let's do the organic circle in the background. And so I have a path here, which is empty, and we're going to build the path. So we're going to do 4 points and then add the control points to these 4 points to have a perfect circle. Hey, let's do it. So we move to the, I mean, it's like a rectangle, but like, so we move to, I hope it's going to make sense, but we have the center. So to CX, I mean, here again, Copilot gives you the right answer. So CX in the middle, and we go up, so minus R. And then we do a cubic 2, and then, so the destination is going to be CX plus R. So we go to the right side, and we are in the middle, so and CY. And the first control point is going to be the previous point, and the second control point is going to be the destination, and that will give us straight lines. So here we know the first control point is CX, CY minus R, and then the second control point is the destination, which would be CX plus R, CY, and then same point for the destination. So yeah, okay, we see something already appearing. Then let's see if Copilot is correct. So this one should be the destination. So CX, CY plus R is correct. The previous point. This one should be the destination, and the destination is CX. So this CX and no, that's not correct. Is it? Oh my God, I'm getting confused. So we go to CX. So it's CX plus R. CY is the destination. That's what we wrote here. Actually, this was correct. And now let's see if Copilot can infer the next point. CX plus R, CY, no. So the destination here is, yeah, that's correct. You see it, right? So we see a triangle. Let's see if it can infer the last one. So the one which is on the left side, so that would be, no, yeah. So here's the previous point, that's correct. Minus R in the middle, in Y, okay, this is correct. Oops, I didn't correct. Yeah, we see it. And we can do the last one to close. Let's see, it seems to be correct. Here I didn't even check, but I see that the result is good. And should I make, I'm wondering, should I make the radius maybe bigger? 100, it's too big. 75, scale the icon. Something smaller, okay. I think maybe it's gonna be too big, but whatever, okay. So now we need to make it a circle. So we know that we need to create some distance to the control point, which is this constant times radius. So let's add, so here we do plus R times C. So we go on the right side. And for the second control point, we do minus on the y-axis. So we go to the top, minus R times C. You see we have like a quarter circle. So let's just do it for each point. So the next one is plus, so we go down, R times C. And you saw the visual, right? So from the visual previously, you saw the directions of the control points, and we just the distance is radius times C. So then the second one goes to the right side, so it's x plus r times c, so this should give us half of the circle, and it does. Here there would be x minus, so we go to the left side, r times c, and here we go, we go down, so plus r times c. 3/4 of the circle, let's close it. That would be minus r times c, and to close this one, minus r times c. So now we have a perfect circle, and now we want to move slightly the distance of these control points, so to give it this organic flavor. So we're going to create a simple Perlin noise for each of these curves. And here I can remove the frequency and amplitude. We're going to start from scratch. So I'm going to create 4 noise, 1 for each curve. And the way we can create a noise, so it's version 4, new version of the API. So we need to set a seed. I think it should be like this. Yeah, looks correct. And I need to do this 4 times. 2, 3, 4, and just a different seeding value here. And so we're going to create 4 deltas. So delta 1 is, so amplitude, let's take 1, and some frequency, let's take 1. So we have amplitude times noise, clock.current, times frequency, and for the Y parameter, we can put 0, and we need to do this 4 times. And one thing we can do directly, so we know here the frequency needs to be a very small value, because if not, it's going to go extremely fast because of the clock value, which updates every millisecond. And the amplitude, we know that it's going to go from -1 to 1, so 1 pixel only, so we can already like maybe multiply it by 10, or either 10 or either some proportion of the radius, so maybe 20% of the radius. I don't know, we'll tweak these values. So here, I want to add D1 minus D1. So here now it's D2, so plus D2 and plus D2 here. So every time we have the C distance, I add the delta. So minus D3 plus D3 and minus D4 minus D4. So you see, but now it's shaking uncontrollably, but we can just put a really small value. But that actually doesn't look so random. Is it because of the, I'm wondering if, is it because of the seeding? No. Maybe, I don't know, I can go a bit faster, and no, it's too... But actually it doesn't look... Or is it way too fast actually? And if I do... That looks a bit better, but not so great. Ah, yes, of course. So you guys might have catched it already. Here I'm using the same noise every time. So let me... sometimes you see I just put back the seeding values, yeah, which I have here and here. So you probably have seen, you see, so it didn't look really random. Now it looks really random. And we can make it slower. It's still a bit too fast, huh? And yeah, now that looks natural. And one quick thing we can do for good measure is to rotate it. So we could rotate through the group directly, but we can also directly rotate the path using a matrix. So I'm going to do a skia matrix. We know that, so we can do rotate. We can use clock. So rotate here is a radian value. And I mean, even times frequency, we can apply the matrix to the path. And of course, it's going to rotate somewhere. Yeah, that's expected. And we can set the origin to the center by doing translate center X, center Y, and back. And how it rotates nicely. Guys, I hope you enjoyed this example. We looked at different ways to do path interpolation, which is going to be really useful in tons of use cases. The Gooey example can be used in really different kind of examples, and the integration with Fluber to do any kind of path interpolation. And thanks to the integration with Skia, it's very fast path interpolation. So a really fun example. And then we looked at using Perlin Noise to create a nice organic effect to the animation. The next Can It Be Done in React Native tutorial is going to go somewhat deep into the topic of Skia shaders. So I am looking forward to talk to you soon. And until next time, happy hacking.